What's up? We are going to continue with differentiation rules, but this time for products and quotients and then some more trig. All right, it's very important. When you're multiplying functions together or you're dividing them, you can't just take the derivative one at a time like you can with adding and subtracting. Okay, that we have our own rules. They're called product and quotient rule. So if we're multiplying, all right, and this is the rule that I use the most often. If we're multiplying, what you do is you take the derivative of the first function and then you multiply that by the second function unchanged, put a plus sign, and now your first function is unchanged, and you multiply that by the derivative of your second function. Okay, so you take the derivative of each function one at a time, and the other one doesn't change, and you multiply them. Okay, so let's practice. I have y equals this mess, and I want to find y prime. So here I have two functions being multiplied together. So I'm going to take the derivative of x cubed first, and then leave cosine unchanged, plus, now x cubed goes unchanged, and I multiply it by the derivative of cosine, which is negative sine. Right, and that's my product rule right there. Now remember, if you have a plus or a minus, you don't have to worry about all of this. You can just take the derivative as is. So minus 2, and then the derivative of sine is cosine. All right, and we could simplify that a little, but I'm not going to worry about it. The quotient rule is a little more complicated. What you do is you take the derivative of the top times the bottom unchanged minus, now the top is unchanged and you take the derivative of the bottom. So just like with product rule, you take the derivative one at a time. This time there's a minus sign, divided by the bottom squared. Okay, so it's very similar to product rule, only difference is now there's a minus sign and your bottom function gets squared. So let's practice. Here I have sine of x over x cubed. So I take the derivative of the top, which is cosine, times the bottom, unchanged, minus, now the top is unchanged, times the derivative of the bottom, so 3x squared. All that is being divided by x cubed squared, or x to the 6th power. All right, let's keep going. Okay, this example is very similar to one that we did in the previous notes. Remember, if you're dividing by one term, okay, if you're dividing by one term, it's easier if you just divide everything by that one term. Okay, so what I mean by that is I have x squared plus 2 over x to the 1/4 power. It's going to be way easier instead of doing quotient rule to divide x squared by 1/4 and divide 2 by 1/4. So remember, we can split this fraction into two fractions. All right, so remember when we divide, we're subtracting. We're subtracting our exponents. So I have x to the 1 3/4 or 7/4 plus, and then we have 2x to the negative 1/4 power. Okay, now I can take the derivative of this kind of normal. Okay, I'm just adding. I don't have to do product rule or quotient rule here. So the derivative of x to the 7/4 will be 7/4 x to the 3/4 power. And then remember, I have to multiply my coefficient and my exponent. So minus 2 times 1/4 is 1/2 x to the, and I subtract 1, so negative 5/4 power. All right, so much easier than doing quotient rule, and I get a much prettier answer. All right, let's keep going. Now some trig stuff that honestly you're going to have to memorize. We will prove this in class, but you got to memorize it for now. The derivative of tangent is secant squared. The derivative of secant is secant tangent. All right. The derivative of cotangent is negative cosecant squared. And the derivative of cosecant is negative cosecant cotangent. So you kind of see there's kind of a pattern here. Tangent goes with secant, cotangent goes with cosecant, right? We will prove some of these in class. But for now, those are just things that you're expected to know. Okay, that's kind of a memorization thing. Okay, so let's practice using the derivative of tangent. Okay, I have a product here. So I have 3x squared and tangent. So you can kind of think about this as 3x squared is our f of x and g of x is our tangent function. Okay, so just like I defined before, okay, one of my functions is f, one of my functions is g. Okay, now if I take the derivative, I get 6x. If I take the derivative here, I get secant squared. Okay, and another way of thinking about product rule is you can kind of cross these. So f of x times g prime and f prime times g, and that's my product rule actually. So if this method helps you, then go ahead and use it. So my f prime is going to be f prime times g, so 6x times tangent, plus, and now my other cross here, so 3x squared times secant squared of x. All right, and this is my f prime. Okay, so if this method helps you, then go ahead and use it. It's pretty good. All right, last example. Whoops, last example. So sometimes you don't have a function, but you're still given some function value, so it is still possible to find some derivatives and stuff. All right, so here I'm defining f of x to be g of x times h of x, and I want to find f prime of 2. I don't know what f or g or h are, but I have these values here. So if I want to find f prime of x, now this is a product rule situation, so it's going to be g prime times h plus g times h prime. Right, now I want to find f prime of 2. So that means that I'm just going to plug a 2 into each of these parentheses, okay, because I want to evaluate where x equals 2. That's not a 2. All right, and now I'm going to look at these evaluations that they gave me, these function evaluations. So g prime of 2 is negative 4. H of 2 is negative 1. G of 2 is 3. H prime of 2 is 5. So I get 4 plus 15, so 19. And that's my f prime of 2. All right, that's it for these notes. I'll see you all later.